Hello everyone, I'm Michael from Datong Forever Energy. Today I'd like to introduce you the assembling process of solar photovoltaic power generation system. We have mentioned about the whole system designing, analysis of cost and efficiency, etc. before. So, our course today would be more focused on the actual constructing aspect of the system. We will be discussing about the different types of frames which match different types of rooftops. We will start from the basic information regarding the framing installation, following by the procedure of canopy frame and inclined rooftop frame installation and some pictures of them. Then we will talk about some additional important notices regarding the construction of concrete basis blocks. This chart shows the whole installation process. Before actually start the construction, we do lofting first. What does this lofting serve? It shows us how we should place our system correctly. Sometimes if you do the construction directly without doing lofting first, you would end up not being able to do any adjustment when finding out that shadows covered your panels, for example. That's why lofting is very important. It's like a testing process for us to examine and find out the best placement of our panels. Secondly, after lofting, we start to do the rebar planting. This is the stage when we secure the location and start working on the basis. Thirdly, we install the frames onto our rebar or concrete basis blocks. In the following, we install the solar cell panel module onto the frames. After that, we work on the reinforcement of the basis blocks, and then finally, we cover the bases with waterproof glue to prevent the air moisture or any other form of water from leaking into our structure. As it is mentioned here in the list, we will have blueprints to help us while doing the lofting. We mark the shadow areas of our construction site on the blueprint, and then we avoid them while doing lofting. Regarding the rebar planting, we firstly drill holes at the places we plant, then we clean the dust up. After that, we put in the rebars and then fill in the construction adhesive to reinforce the stability and becoming waterproof at the same time. In the following, we install the metal frames for our panels to sit on. After the installation, we should do leveling with bubble level and secure that screws are perfectly tight. When the frame is done, we put on our solar cell modules according to our plan and blueprints, avoiding shadow areas. This is how it's like when we're doing the pre-construction lofting process with leather tape or other measuring equipment. We do the process according to our original plan. We mark the location of the frames and then measure the structure's size accordingly. Once we're sure about where to construct and the frames don't clash into each other, we start a drilling process. If there's insulating brick on the rooftop, then we cut them open before drilling, for our frame to fit into the whole building structure. After the drilling, of course, there's going to be a huge amount of dust, so we must clean it up. After the cleaning, we put in our rebars. When the rebars are in position, we use construction adhesive to fit in the interstice to furtherly secure the structure. Then we install the columns of our panel supporting frame. After the columns are in position, we clean the dust again before applying the polyurethane waterproof layer to prevent water from going into the bases of our structure or even into the interior of the building. In the following, we install the whole supporting frame, like the skeleton of our panel's construction. After the skeleton is done, we put on the most important part, the solar cell panels. The final step of our work here is to secure the bases again. We surround the bases of the columns with wooden molds, then fill in the cement to create concrete blocks. Once the cements are dried and we got our concrete blocks, we once again apply the polyurethane layer onto the blocks to enhance the waterproof ability. We do all this work to all our columns. That was the construction method for flat rooftops. Now, when it comes to inclined rooftops, it's actually pretty much the same regarding the process. We need to do lofting first as usual, yet in this case, we don't necessarily have to use rebars. Rebars don't apply to some inclined rooftops. Sometimes we choose to use other type of columns to directly hold on to the slates. Then the following steps go back to the same path: skeleton frame installation and the panels. Here you can see the steps listed out. It's all very similar. First, we do lofting according to our blueprint to check the shadow area and the type of slates for us to decide which type of column to use. Regarding the waterproof work, aside from polyurethane paint, we also use silicone glue to fully cover the bases in this case. After the cell panel modules are fully set up, we make sure that the connector of the electrical wire network stay on the metal framework. It can't be placed on slates or any other places where it might be regularly scarred by water. The other reason why we avoid the contact between the connector and the slates is that during summer the high temperature on metal slates might damage the connector. These are the photos of lofting process on inclined rooftop. As you can see in the picture, the rooftop is covered by tiles. In this case, we can do the drilling and rebars planting part as we do on flat concrete rooftops. Like what we do on the flat roofs, we drill, clean up the dust, and then fill in the adhesive. We also plant the rebars and secure them with silicone glue, and then we construct the metal frame on it. Then we lay the panels on. There are sometimes certain differences regarding the structure of our metal frames. As you can see in the left picture, there are no diagonal bracings in between the columns, but there are diagonal bracings in the right one. Our decision in putting diagonal bracings or not is based on the environmental factors of our site. For instance, there are diagonal bracings installed in the right picture because the average wind speed is stronger over there in comparison with the other sites. In the picture on the left-hand side, we connect the frames by welding, but in the right picture, we use L-fit supporting parts to do the connection with screws. Why the difference in such matter? We decide the method by considering the costs and the environmental factors. We used to do it all by welding since it costs less. Yet some of our sites had rusting problems at welded parts, hence some sites must be done with additional supporting parts. Here we discuss about the advantages and disadvantages of welding. It is faster and more convenient if we construct the frames by welding. Yet, once we make any mistake in calculating the distance of each connection point, there will be no chance for us to fix it. Plus, we can't afford any risk of collision during transportation. The damage would be irreversible. Now let's talk about the other methods of connecting frames with additional L-fit parts. First of all, it has lower collision risk during transportation since the frames are still unconnected. On the other hand, if there's any tiny difference in terms of measurement, we're able to adjust them accordingly. Plus, we can add diagonal bracings to increase the resistance to wind pressure. The downside of this constructing method is that it costs more in terms of budget and working time. Now, we talked about the important points of our last steps in construction, the reinforcement of concrete bases. Firstly, before we pour the cement onto the bases, we must make sure the basis is clean, preventing the concrete from cracking in the future. Also, the wooden molds must be clean as well for the shaping to be perfect, which promises the strength of the structure. While pouring the cement, we must stir it to prevent bubbles occurring inside. After the whole process, we must do regular maintenance for the same reason. Here, we can see the whole construction process presented in chart. From lifting sling, to lofting, to drilling and waterproof layer printing, to structure and panel module installation. Till this point, they all belong to the metal framing construction. After the framing construction, we proceed to the electrical part of our work. From the wire network of the modules, connection to DC box and inverter, and then the integrated output goes from inverter to AC box, then go to the public network owned by the electricity company. In comparison, the electrical wiring is faster and easier than the construction part. Here, we can see the photo showing the lifting sling process. After arriving to site, we need to check our inventory to make sure the quantity of everything is correct. This includes the inverters. If the site needs, for example, 52 kilowatts of power generation, we need to prepare the correct number of inverters accordingly. Usually, we prepare the metal frames with the module simultaneously since it will be more convenient and time-saving. After we put everything on top of the roof by lifters, we start the lofting work to get a general layout plan according to blueprint. The blueprint is so detailed that the angle and all measurements of the structures are all included. When we're doing the lofting, we see that not every piece of open ground can be used for constructions. According to the blueprint, these areas covered by blue purplish dotted lines are the shadowed areas. We also need to keep certain distance between each structure for them to not shadow each other. The points where we plant our columns are all marked on blueprint as well. We must follow the instructions strictly, otherwise any small deviation might sabotage the whole plan. This is why lofting is so important for the whole construction work. You can see in the photos that we marked the dots on ground after lofting. These dots mark the correct ubication where we will be planting the rebars and then the whole structure. Speaking of the drilling and waterproofing, it's like what we have talked about before. We drill holes, clean up dust, pour in the adhesives, insert the bolts or rebars, paint the waterproof layer, install the columns, and then add in the waterproof concrete bases. Now let's proceed to the module laying part. We lift the metal structures onto the rooftop or other sides, and then assemble them. We must do the assembling first before we lay our panels. Sometimes when the workers are not so experienced, they unbox the panels before we even have the framework assembled on rooftop. That will cause a lot of serious problems since each piece of them weighs up to almost 20 kilograms. Yet, this problem wouldn't be so serious if the site is on ground or by water, since we don't need to lift things up. Like what we've mentioned in previous classes, if the site is by water, we do the assembly on the wooden platform on the bank. Hence the convenience in laying. Yet, there's one thing to keep an eye on if we're doing it on water. Our panels can't cover the whole water body, otherwise it will affect the original local water usage. Now we talk about electrical equipment installation. This stage of work starts right after our panels are all set. We do the wiring beneath the panels and connect them with our electrical network to the DC box more precisely. We use cable trays to cover and protect the cables coming out from our panel modules. After the DC box, the cables go all the way to the inverters and then to the AC box. The cables are all covered during their whole journey from the potential threats caused by weather or insects. As you can see in the picture, inside the AC box, there are many switches. A small switch corresponds to one inverter. On the other hand, a bigger switch corresponds to up to 5 inverters. And then the biggest one is our main switch. This is where we transfer the energy generated by our modules out to public network. In the panel module section, the electrical currents are direct, yet it will turn into alternating when we transfer them out. We take care and examine every part of our work very carefully. We even differentiate the stand-proof paint according to the distance between our site and the coastline. If the site is within 2 kilometers range from the coast, we use better HDG stand-proof paints. Why do we care so much about every details? Take Taiwan for example. The duration of the contract we sign with the electricity company usually goes longer than 20 years. If any detail goes wrong, the problem will be significantly magnified. Here are the aerial views of different kinds of our sites. You can see in the top right picture that the site was built on a slope. It was a more uncommon situation. We gave more effort into calculating the distance between the panels due to the angle of the slope. And you can see that there is a white object in the middle of the panels. That's the AC box. The top left picture is a common inclined rooftop case. The bottom left picture is an oval inclined roof. Why are the spots crossed by me not covered in panels? That's because there are lightning rods at those two spots. Finally, the bottom right picture is a water site. You can see that the area covered by the panels is way smaller than the actual size of the pond. This is because we need to save the space for its original usage. We need to keep all the records and documents for our sites for other people to do the maintenance correctly, since the sites will be serving for at least 20 years. Now, there are a lot of orphan sites which the original company didn't take care of after they were built. Our company take over the responsibility as well. We evaluate, renew, and maintain them. So, this is the end of our class. Usually speaking, when we're surveying our sites, we don't just go there. We also use drones to do the evaluation and data collecting from different angles. For example, the rooftop we see in this picture. We plan to place our module in that corner, so before the construction work, we survey the rooftop by using drones to take pictures of the roof and the surrounding area of the building. In this aerial view of this site, since our target building is fully shown in the picture, we can start the measuring work according to the picture. After the measurement, we plan our work and do the whole construction. Now, this is a more basic version of the blueprint of our module site. The blue checkers you see on the plan indicate the metal frames, and the picture on the top right is the side view plan for an individual module. This kind of blueprint is what we do after the site survey. Now, this complicated chart is the wiring plan, which maps out the whole process from the wires attached to the panels to DC box, inverter, and AC box. This is the map of all the cables we're going to install. As you can see, this is a church in the photo, and the structure we did is right behind the Holy Cross. They had a set of panels in the back corner. We left it right there untouched. The L-shaped bigger set of modules is our later work, which is what you have seen on the blueprint I just showed you. We didn't touch the original power panels they had. We added the bigger L-shaped one and another section on the metal rooftop behind the church. You can see all the pictures while I do the narrative. This is another aerial view of the church site. Now, this is how an actual AC box looks like. Then, we find a suitable spot on the wall to install the AC box. Now, these refrigerator-like objects are the DC boxes. We lay the wires after the installation of all this equipment. We set our wires on this rooftop, and then we connect the cables from rooftop into this box right there, and then we connect them to the inverter. After the cables are connected to the inverter, they go to the AC box. Here are some more pictures for your information. Now this picture is the AC box. All cables will be integrated into this box for us to have a general control. This is the arrival of our inverters. This situation here is after the discussion of where to put our main control. We put the AC box right here. This is the interior view of the AC box. This number shown on the panel is the power generating data. And this is what we have mentioned. We must cover our cables like this. This is how the inverter looks like and the related data. After everything is done and secured, we cover the cables up and seal them with special stickers for people to know that these cables are for the power panels. We mark all the cables with our special stickers for people to know what these cables are for. This is how a completed site looks like for your information. This case is a special one. The power generated didn't go to the public electricity company. It's for the tribe's usage only. Okay, thank you for your attention.